Your refrigerator has no way to make cold. None. There is no cold in there. There is a machine quietly stealing the heat out of your food and shoving it out the back into your kitchen. Right now, your fridge is warming your kitchen to keep your milk cold. Once you see that, you cannot unsee it. And it is the exact same trick as your air conditioner and your home heater. Cold is just what is left over when the heat leaves. Here is the one rule that makes the whole machine make sense. Heat only ever flows on its own, from warmer to cooler. So to make your food colder than the room, you cannot let nature run. Nature would warm the food up to room temperature, not cool it down. You have to actively pull the heat out and carry it uphill against its natural direction. That takes a pump, and it takes energy. That pump is sitting in your kitchen right now, humming. Learn its 4 parts once, and you will see why your fridge, your AC, and your house's heater are secretly one machine. Watch for it. Here is the whole machine. It is a sealed loop with a special fluid inside called a refrigerant, chosen for one talent. It boils at a very low temperature. And because the coil inside the fridge is kept at low pressure, the refrigerant can boil colder than your freezer. Keep that in mind, because the boiling is the trick. The loop has 4 parts. Follow the refrigerant around. Part 1, the evaporator coil, inside the fridge. The refrigerant arrives cold and low pressure as a liquid. Your food and air are warmer than it is, so heat flows from the food into the refrigerant, and that heat makes the refrigerant boil into a gas. This is the actual moment of cooling. Boiling sounds hot, but boiling is just a substance absorbing energy to change from liquid to gas. Your sweat cooling your skin is the same move. The refrigerant drinks the heat out of your food and carries it away as a gas. Part 2, the compressor. This is the pump, and this is the part that hums. It grabs that low-pressure gas and squeezes it hard, which concentrates its energy and makes it hot, now hotter than your kitchen air. That squeeze is the hum you hear. Hold that thought, it explains everything later. Part 3, the condenser coils, on the back or underneath. The refrigerant is now a hot, high-pressure gas flowing through coils exposed to your room. Because it is hotter than the kitchen, heat flows out of it into your kitchen, the natural direction again. As it sheds that heat, the gas condenses back into a liquid. All the heat that was in your food, plus the energy the compressor added, is now radiating off the back of your fridge. Part 4, the expansion valve, a tiny restriction. The warm, high-pressure liquid gets forced through a narrow opening into the low-pressure side. The sudden drop in pressure lets it expand and flash cold, very cold, ready to drink up more heat. The loop closes and runs again. That is it. Absorb heat inside, squeeze, dump heat outside, expand cold, repeat. Engineers call it the vapor compression cycle, the most common way anything gets cooled on Earth. And this same back-of-the-fridge trick is about to explain your air conditioner. But first, the warm back. Put your hand near the back of your fridge, or the grill at the bottom. It is warm. People find that strange for a machine whose whole job is cold. But you already know why. Those are the condenser coils, and that warmth is literally the heat that used to be in your food, leaving the building. Your fridge is a heat conveyor belt. It picks heat up inside and sets it down outside. The inside gets colder only because the outside gets warmer. So if it is just moving heat, why does it turn itself on and off all night? That hum is the compressor running. But it doesn't run all the time. The inside is a thermostat watching the temperature. When the air drifts up past the target, the thermostat switches the compressor on. The loop runs, the box cools back down, and the thermostat shuts it off. Then heat slowly leaks back in through the walls and the seals. The temperature drifts up again, and the cycle repeats. That on-off pattern is called a duty cycle. It is why your fridge is quiet for a while, then hums for a while, then clicks off. It is not broken, and it is not straining. It is holding a temperature by running in bursts. So if the compressor only has one speed, what does turning the dial actually do? Here's the myth almost everyone believes. If the milk is not cold enough, turn the dial colder and it will cool down faster. It will not. The dial does not control speed, it controls the target temperature, the thermostat set point. The compressor only has one speed in most fridges: on. Turning the dial colder does not make the loop run harder or pull heat faster. It just moves the finish line lower, so the compressor runs more often and for longer to hold that colder target. Your food cools at essentially the same rate either way. All you have changed is the destination and how much electricity you burn getting there and staying there. Colder is not faster. Colder is just colder. So what happens the moment you open the door? Every time you open the door, two things happen. The cold air, which is dense, slides out the bottom and pools on your floor, and warm room air rolls in to replace it. You did not let cold out so much as you let heat in. Now the box is warmer than its target, so the thermostat fires up the compressor to pump all that new heat back out. Standing there with the door open, deciding what to snack on, is basically asking the machine to cool the room a little. Close the door, know what you want before you open it, and the machine does less work. Which raises a question about the coldest part of all: what exactly is the freezer? The freezer is not a different machine. In most fridges, it is the same loop or a close sibling of it, simply run to a colder target. Usually around -18 degrees Celsius, about 0 Fahrenheit. Same refrigerant, same compressor, same condenser dumping heat out the back. The refrigerant just gets run to a lower temperature. And often the coldest air is made in the freezer section and shared with the fridge compartment beside it. Colder target, more heat to move. So the compressor runs a bigger share of the time. Same 4 steps you already understand. And those same 4 steps are about to do something much bigger than chill your food. Now the big reveal. A refrigerator, an air conditioner, and a heat pump are the same machine. The only difference is which way you point the heat. A fridge moves heat from inside the box to your kitchen. Small cold space dumps into the room. A window air conditioner does the identical thing at room scale. The evaporator coil faces your room and drinks its heat. The condenser coil hangs out the window and dumps that heat outside. An air conditioner is a refrigerator for a room, and the outdoors is its kitchen. That is why the outdoor unit blows hot air. A home heat pump is the same loop with a valve that can reverse the flow. In summer, it pumps heat out of your house to cool it, exactly like an AC. In winter, it runs backward, pulling heat from the cold outside air and pumping it into your house to warm it. Yes, even cold outdoor air has heat in it to grab, right down to some very low temperatures. One machine, heating or cooling, just by choosing a direction. Same 4 parts, same vapor compression cycle. The fridge in your kitchen is a tiny one-direction version of the system that heats and cools entire buildings. This is the Whambox part where we tell you the catch, because the mechanism has real downsides. First, your fridge is a net heat source for your kitchen. It dumps out more heat than it pulls from the food because the compressor's own energy gets added to the pile. A running fridge makes your kitchen slightly warmer, not cooler. Leaving the door open to cool a hot room does the opposite of what you want. Second, the duty cycle means it is never truly off. It cycles on and off around the clock to fight the heat constantly leaking back in. That is normal, but it means the machine is always working in the background. Third, dusty coils quietly cost you. Those condenser coils shed heat by touching room air. Cake them in dust and pet hair, and they cannot dump heat as easily. So the compressor runs longer and harder to hit the same target. Vacuuming the coils once or twice a year is one of the few genuinely useful maintenance moves there is. Fourth, it is a meaningful always-on load. Any single moment it is running does not draw a huge amount, but it runs part of every hour of every day for a decade or more. Added up, the refrigerator is often one of the larger always-on electricity users in a typical home. Small and constant still adds up to real money. None of this makes it a bad machine. It is one of the most quietly reliable appliances ever built. But it is a heat pump with a duty cycle and an electric bill, not a magic cold box. So one more time, Your fridge does not make cold. It pumps your food's heat out the back, which is why the back is warm. Cranking the dial only lowers the target. It does not cool faster. And a fridge, an air conditioner, and a heat pump are one machine pointed 3 different directions. Cold was never the product. Moving heat always was. Subscribe to Whambox for more How Does It Actually Work explainers.